All right, and we're live. All right, Atlanta. All right, Joe. All right. Welcome to this session on building and consuming FoxPro REST API services. So in this session, I am going to be talking about building web services using the REST architecture, basically. And of course, we're doing this from the FoxPro perspective. So we're going to be looking at how to call services from FoxPro using various tools to make sure that we can serialize data, that we can send HTTP requests. And then we'll also look briefly at how to implement the REST service so that if you want to share data using a web service, we can do that with the tools that I'll show you. Okay, so let's get started. So REST, yeah. We all could use a good rest after the last couple of years that we've been having. So it'll be good to rest like this guy there. So what does rest mean? If you look at that term, the actual terminology for that is representational state transfer. It's a pretty vague term if you think about it. And if you look at that, you're probably going, huh? What does that mean exactly? Well, I'll talk about that in the next slide. But the first thing to understand about REST is that it's not really a fixed standard or specification. You can't go to some website and actually look up the spec for this because it's really just a set of recommendations that are built around the HTTP protocol. So really, when you think about REST, you think about HTTP and how HTTP works and how you can pass data between client and server and use the semantics of the protocol, like caching, like the encryption via HTTPS, via authentication, and so forth. That's all handled through the HTTP protocol. And REST is basically a specification of recommendation that sits around these the HTTP protocol, essentially. So what we're talking about here is essentially building services that sit on a web server. So you have a service that sits there and can be accessed by any client. It's not really anything new. I mean, we've been building services for a really long time, right? I mean, how many of you have built SOAP services in the past, perhaps, or called SOAP services in the past? And REST is basically very similar in terms of what it accomplishes in terms compared to SOAP. The problem with SOAP in the past is, and anybody who's used a SOAP server or built a SOAP server before probably has run into that, is SOAP became an incredibly complex technology. There is schemas that you have to worry about. There's a specific service envelope that goes with every message. And then various platforms had different ways of interpreting how messages were sent and how things were formatted, especially when it came to security. So that almost calling every single service, you had to sit down and exactly figure out how to call this service and make all the intricacies work. So REST tries to address that by simplifying the entire process and just going with the basics of the protocol, basically the HTTP protocols. So if we break down the term representational state transfer, what we have there is the representational part, which basically refers to the unique addressing, which is essentially a URL plus an HTTP verb. So a post request against a specific URL is different, for example, than a GET request against that same URL. So those are two different entities, or they're considered two different entities. But a URL by itself is unique in terms of addressing, right? So you can always go to that same URL in a browser, and if you running a GET request, you are going to get the same result each and every time. If you change the URL and you add a different parameter to it, then the URL changes and it's no longer that same resource. It's actually something different. So by the representational part basically means that we have a unique mechanism for addressing a request or an endpoint to process the actual request. The state, so in the representational state transfer, the state is the data that travels between the client and the server. And what we're talking about here is the payload, basically, the content. So that would be, in most cases, JSON. Now, REST doesn't say that you have to transfer JSON. You can send XML, although that's very rarely done these days. But you can also send other things like binary data. So in some cases, you might need to upload an image to a server, or you want to download a PDF file that comes back from a report. So those are binary files or binary data, and you can send that data back and forth as well using other mechanisms than JSON to send the data up. So for example, a binary upload would most likely use a multi-part upload using standard HTTP features. And finally, there's the transfer. And the transfer is the most important part of REST probably, which is the HTTP protocol. So all the things that make up HTTP, the URL addressing, the port 80 and port 443 for HTTPS requests, for example, the HTTP headers that go with each request and each response, the standard headers that actually describe the operations, the content type, for example. All of those things that make up the HTTP protocol, that's the transfer part of representational transfer. So in simple terms, if we break that all down, it's really just a client calling a server and all of that transaction happening over HTTP. Now that brings with it a whole bunch of benefits, just like it does with other service-based architectures. And that's basically that the client and the server are completely disconnected from each other. Right, so you can swap out the client and use a different client. So in this screen, in this image that you see on the right there, you have phones, browsers, and desktop applications all connecting to the same service API. And each one of those applications could be using a different language to connect to that server. Because it's an HTTP-based API, it's accessible from anything, from any tool that has access to a HTTP client and a JSON parser, and then you can make these calls. And what that means is you can swap technologies at any point in time. You can also swap the server out. If you put a different server in there and leave the API exactly the same as it was before, but behind all the innards are completely different, so you switch from FoxPro to .NET or vice versa, you can do that because this is basically a very disconnected architecture. So both the front end and the back end can be are basically swappable, and that's a really powerful feature. And as I mentioned, HTTP has become the ubiquitous protocol for building applications these days. So everything pretty much runs over HTTP, and HTTP has access to goes through the networks. Right? You don't have issues with proxies and firewalls. So HTTP can go pretty much anywhere. So any application can call that without too many security implications in terms of trying to get to it. So in the past, for example, with SOAP, you had to worry about TCP/IP services in some cases, and then you couldn't get through the firewall to get to a certain location, for example. So HTTP provides a lot of benefits here by being a standard interface that's accessible from anywhere, easy to implement in terms of code. All you need is an HTTP client, and it has a whole bunch of functionality built into it, like caching, the security via certificates, and so forth. And we'll talk more about that in just a minute. So what am I talking about here? So if we actually take a look here at what a REST request looks like, let's run this request against a test server here. So what I'm actually going to use here, let me see here. Let me bring up the site that we're going against. So this is a site that I built a long time ago, actually. It's an album viewer, and it's basically a bunch of music albums that get served on a web page here. Now, this application actually uses a service backend to service all this data. So this HTML is not generated as an HTML-based interface from a server backend, but rather it's served from an API service that serves all the data that is being displayed inside of here. So if I navigate through here and drill in, all of the data that is actually being displayed here comes from a service that is pushing just data into the page, and then an Angular front end, a SPA application, basically takes that data and turns it into the HTML via that framework that provides the HTML rendering services. So the rendering doesn't happen on the server, but it actually happens on the client. And the only thing traveling over the wire in this case is the JSON payload in this case. So this actually highlights another point that I forgot to make in the last section there, is that there are two kinds of applications that you end up building with API services. One is a SPA application like I'm showing you here, and the other is API backends to other applications that live in other places. So if you have a integration point with a credit card service, that might be a REST service that is exposed by the credit card company, and then thousands of other people are using that REST API to talk to that credit card company and do their processing remotely. So those are two different kinds of scenarios, right? A local SPA application like this browser app, or a remote service, an RPC service basically, that allows you to interact with some service that provides functionality that you need. Okay, so if we look at this here, the actual requests going over the wire, I'm calling that same API service that I was just using with the web application, but I can also access this remotely now. So I can use FoxPro, or I can use .NET, or I can use a mobile application, all to connect to that same data that the web browser was using, right? So this is basically that interface that we were looking at here. We could all be addressing that same application through that interface. But when we run this request, right, so we have a request with a verb, an HTTP verb that says, get me the result data from this. And the get just means retrieve data, don't push anything up to the server, right? And then we'll have a unique URL that identifies this service actually. So if I click on this and we bring this up in the browser, that also works, right? It's that same URL in the browser. Or I can use a local client like a FoxPro application, for example, to pull that data down. And we'll do that in just a minute. But so an HTTP request is made up of a URL and an HTTP verb plus a bunch of HTTP headers. So the HTTP headers is basically metadata that describes the request that you're making. And in that metadata, you describe basically what kind of data do I accept, what do I want to retrieve. And if you're sending data, then you also need to tell it what you're sending to the server. And then when the request returns from the server, you get an HTTP result that always has a status code associated with it. So there's a status code of 200, which means it's okay. Okay, so that means the request worked. But there's other status codes like 401, for example, unauthorized, or 500, it's a server error, or 404, not found. So these status codes are very important to the protocol. They basically let you know that something didn't work if something goes wrong, and you can kind of get an idea just by looking at the HTTP status code alone that the request failed and what the failure was. So some requests may fail on the server with a hard failure that you can't actually return any information as part of your application itself. So you get a 500 error and there's no further information. But when you do get that 500 error, at least at that point, you know that something went wrong and the server can immediately respond with that server failure. In other situations, you can actually send an error request and then send a result back. So in this scenario, for example, this is a hard server error, right? This actually failed with this method is not allowed on that server. But if I go, for example, for a login request and I fail this request, right? So now I'm unauthorized, but now I can actually send back from the server an additional response that said, okay, well, here's the actual error that occurred, an invalid login credentials, right? If I run that same request now with a valid username and password, then I get the actual result and a 200 okay response that tells me, hey, it worked. And here's the token that is needed for the next request that I'm going to hit on the server. Okay, so since we're on this login request, notice here that this is a request that is a post request. So this is actually sending data to the server. So the client in this case, so this could be a FoxPro application, is saying, I want to post some data to the server, and I'm going to send this data right here. And the content type of that data, and this is the important part when you're sending, is application JSON. So you can send other things, right? You could send text XML and then have an XML message. That would also work as long as the server knows what to do with that. typically in REST application, you're always going to end up with application JSON. And then the actual payload for that is a JSON string, essentially, right? So in this case, it's a JSON object that has a username and a password, and these values are set and then sent to the server. The server then takes this and processes that request, and based on that request, it returns back a JSON response, which in this case is also an object that has a bunch of properties associated with it. Okay, so two things here. First of all, for those of you that are not familiar with JSON, JSON is a serialization format, and basically it's a JavaScript literal representation of values and objects, basically. Okay, so you can represent a lot of information using this very simple type system that JavaScript uses, which is basically that it only has numbers, booleans, strings, dates, objects, and arrays. Those are the only objects that exist in JavaScript, or a regex expression, but you can't do that with JSON. But there's a few other things, but the base types that you're dealing with are very, very simple. So what that means is that everything can be serialized using a very simple set of types that are available for you to serialize to. So there's not a whole lot of ambiguity between, well, is this one an int, or is it a double, or is it a decimal? It's just a number. So then the client has to figure out, based on what you're retrieving, what type of data it actually is. So compare that to SOAP and XML, where you had to be very precise and you had to say exactly, hey, this is a double or this is a float. And if you didn't pass the right type from the client application, then the serialization would completely fail, usually with some cryptic error message that you would never be able to figure out. So it's not a good scenario to have that. With JSON, all of that gets simplified because the type information is very simple, and it's very beneficial to FoxPro because FoxPro has essentially the same type system, right? We have number, we do have the concept of integers and currency, but for the most part, FoxPro treats numbers as just a number value, and there's strings, there's booleans, and there's dates, and we can map all of these things very easily in FoxPro. So when we look at a JSON object here, so this is an album list, right? So I retrieved an album list from the server. So if we go back over to the browser here and we look at this again and we go to albums, essentially this list that you're seeing here is that list that we're generating here. So when we look at this list, we have a collection. So that's a square bracket, a collection of objects. So here's the object that starts, which in this case is an album. And the album has a title, it has a description, a year, some URLs, and then it has a nested object inside of it with an artist and a nested collection of tracks inside of that album object. So as you can see, you can build hierarchical data lists very easily. And they're very easy to package up and pass down, even with very, very complex data. Now, I would recommend as much as possible not to make things too complex in terms of your data structures, but depending on the services that you connect to, some services that are enterprise-based, they can have these nasty, 10 levels deep levels of objects. And that's entirely possible with JSON, which is one of the things that makes it so nice. And again, it's relatively easy to create JSON from FoxPro and parse JSON from JSON into FoxPro as well. And again, we'll see examples of that a little bit later. Okay. So again, here, this is kind of summarizing what I've just talked about. And it's basically that we're talking about APIs that we're passing over HTTP when we're talking about REST requests. So the most important thing to remember is we have a URL that is always unique, a verb that goes along with it, and that makes a unique request. The HTTP verb plus the URL make a unique request. Then we have headers that get passed. We have the content that we can optionally send on a post and put request. Then the result, the result that comes back brings back a status code. It always comes back with a status code, a set of headers, and then a response that comes back. So that response can be, is always specified by the content type that each and every response returns on an HTTP request.
Hey, Rick.
Yep.
Webcam. Toggle your webcam.
Okay. So when we're talking about FoxPro now and how we can take advantage of all of what I've shown here so far is what we need is some components to make REST work both on the clients and the server. So there's nothing native in FoxPro that provides you that functionality. So the two things that we need is an HTTP client and a JSON serializer. Okay, so when we look at this here, there is there's a couple of things that I am going to be showing you here. There's options available for, there's multiple options available to do both the HTTP serialization and the JSON serialization. Now, I'm a little bit biased, obviously, so I use the tools that I've built. So I'm going to be showing those, but keep in mind that there are other alternatives that are either free or you can get from other places, or you can build your own if you want. It's not that difficult to build some of these solutions. Okay, so keep in mind that these are mostly for presentation purposes and with what I'm familiar with. And so that's what I'm going to show here. Okay, so I'm going to be using these two components, which is the HTTP client and a JSON serializer. So if you look at a request like this artist request that we just talked about a minute ago, to make a GET request and retrieve it is essentially a one-liner with an HTTP client. Okay, so I get this URL and it returns me the JSON in this case. And then I deserialize that and turn it into an object that I can then look at. Okay, and we'll look at that in just a minute. On the server side as well, you're going to need some tooling. There's nothing, well, FoxPro doesn't have a built-in solution for web applications. So again, I'm going to use Web Connection for this because that's what I'm familiar with. And I'll show you an example how we can create a REST server later that allows you to basically make REST calls with single method calls like the one that you see on the right there. So the idea on the server side then is that you have an API that is set up as a process class in Web Connection, and you have a single endpoint method. So every endpoint maps to a method that has a single input object parameter or input value parameter. It could be any object or value that comes from JSON, and that is picked up by the method. And then you can use that input parameter and run your business logic. And at the end of the request, you return back some value that is then serialized into JSON and returned back. Okay, so any questions on this so far?
Yeah, a couple. What tool are you using to inspect your session running on the client side?
Yeah, so I'm using something that is, again, a proprietary thing that I built. So the tool that I'm using here is, let me see if I can, why am I not switching? Not a second. I can get out of my PowerPoint. There we go. So this is Westwind Web Search. And it's essentially a stress testing tool, but you can also use it to test individual requests. So there's also Postman, which is very popular with many people. So as far as the request processing goes, it's very similar in functionality. It's web-based, but personally, I use this because I can also use it for stress testing. And there's a sample version. So this is a preview of version 2. And there's a pre-compiled version that you can actually play with in the samples that ship with this session. Okay.
Okay, and then I think the other questions have been answered by others.
Okay, well, just move along then. Okay, let me see here. I lost my place. All right, so now let's look at calling REST APIs with Visual FoxPro. All right, so the two things that we need are an HTTP client and a JSON serializer. And as I mentioned in the samples here, I'm going to use www.http, but I just want to point out some alternatives that are available to you. So if you look at the white paper, there's an example that uses WinHTTP. So I basically created a real simple WinHTTP client that you can use instead of www.http. So WinHTTP and WinINet and XML Server HTTP are native tools that are built into the Windows platform. So WinHTTP is the latest one of these, and that's probably the one you should use. So they have a COM object and Windows 32 APIs that you can use. For the sample that I built, there is the I use WinHTTP, and it works relatively well, but it doesn't have all the breadth of functionality that you get with a full-fledged tool like www.http or the Chillcat HTTP client, which is another commercial tool that provides HTTP services. So either one of those will work. And then for serialization, you need a serializer of some sort that can take your FoxPro objects and turn them into JSON and then parse a JSON string back into FoxPro objects. And again, I'm going to use the www.json serializer, which is part of Westwind tools. Or you can use NFJSON, which is something relatively recent, but it's actually very good. And you can find it on GitHub, and it's open source as far as I know. So NFJSON is the other option that you have there. And again, I'm using www.json serializer because that's what I'm familiar with. Now, even though I'm using these tools, just be aware that the HTTP calls and the JSON serialization are such a little part of building REST services that it's not really relevant whether you use one tool or the other. The syntax might be a little bit different, but overall that has very little impact on what you need to do. Really what you want to look at is whether you can get the functionality that you need out of these tools. Okay. So JSON serialization, just to give you an idea what you can do with the JSON serializer. So on the right there, you can see the serialization of various different things. So as I mentioned, all the simple types, you can just serialize by simply passing a value and serializing it. You can also serialize cursors using a special syntax that is cursor plus the cursor name separated by a colon. Okay, so you can also serialize collections and then also serialize objects. So in this case, what I'm doing on this bottom part here, after the wait window, is I create a collection, create an empty object, add properties to it. So that's my object structure. And then I'm adding each one of those items to the collection. So I'm adding 2 items, and then I serialize this whole thing up into and just run it. Okay, then I can also turn that around the other way. So I'm creating JSON there, an LC JSON string, and then I can take that JSON string and turn it back into an object. So you can see there, I'm clearing out the object and set it to null, and then go back around to turn the JSON back into an object. And what that gives me is a collection of objects that I can loop through, and I can print out the name of the record and the company. Okay, so JSON serialization is important, obviously, in this scenario. And you can do this manually, or you can use some additional tools that can help you with this. Let's take another look at this. Let me go over here. So if we go into, okay, so if you look at the test here, so this is the test. I'm just going to run this because we were running this. So www.json serializer base types. Let's see if I can remember that. If we run this, this is the first list. So these are all the simple values. This is the collection. And then if I press enter, that's the collection of artists that I'm adding. And then here's the values that come back when I actually loop through this, right? So this is that same code that we looked at there, basically. But the idea is that you can very easily serialize this. And as you can see, these operations are super fast. You can actually serialize a fair amount of data very, very quickly. But if you get huge, huge lists, you do not want to take, multiple millions of records and serialize them into JSON. That's not a good idea, just as it wasn't a good idea to do that with XML. It's possible, it's just going to take a long time, and you may run out of memory. So you want to think about APIs in general, you do not want to send humongous sets of data. You always want to filter the data that you send. Okay. Also, while we're here, HTTP requests, and by the way, these samples that you see here, they are available for download on the GitHub repository that's referenced in the session notes here. Okay, so if I go in here and run an HTTP request, remember we showed that, you can do a simple request that simply gets some albums from the server, or actually artists, that retrieves a single artist. And then on the second request here, I'm going to do a post request. And basically, I create a string of JSON, just hand-coded for now. And you could use the JSON serializer to do this as well. But for now, you could just use a string. And then pass that JSON string to the post method as the second parameter right here. Okay, so this allows me to push data to the server. So if I run this, we get the album that is returned from the server in this first request, and then in the second request, where I logged in basically with the post data of the username and password, I get a result back, and in this case, that's the token. So when we look at this over here, what we just did is basically these two requests, right? So this is the album viewer, this is the artist request, and then this is the login request. All right, so we passed this data in, and we got this response back. And that's exactly what we're seeing here, right? There's the token, there's the display name, and the expires. Okay, pretty straightforward. Okay, so then the next step is, oops, let me kill the camera. The next step then is to put these two things together, right? So now we have the HTTP request, we know how to send a request, and we also know how to serialize data. So how can we do this now in an actual request? So think about this for a second. In this example here, I'm just sending the username and password. But even in a complex application, think about this for updating, for example, an artist. So in order to update an artist, it's actually a two-step process. You first need to be logged in. You need to be able to actually have the information to connect to it, because you don't want to just allow anybody to update your data. And then after that, you need to actually post and go to update the actual record. Okay, and we'll look at an example of that in just 1 second. But before we do that, let's just look at the simple scenario, which is the login scenario. Okay, so here is what I have is I create in FoxPro a user object. So I have a user object, and I add a username and password property to it, and I set it to test. So this is my login information. Then I serialize that to JSON. So that's going to give me basically what we looked at in the web search trace there, right? We have a JSON object that has username and password properties. So I need to specify that what I'm posting to the server is of type application JSON. And then I actually post that data, right? So I post to this URL, so to the authenticate URL, and I take the JSON that was generated here, and I pass that as the parameter. And the result will be then in this case, the token object that contains the token inside of it. So a couple of things that you do want to do in this case is you want to check for errors. So if the error is not 0, you want to display the error message that comes back. So this is if something goes wrong with the HTTP protocol itself. And then you can also check the result code. So if the result code is 401, you can just say that it's the login failed, invalid credentials. Actually, if the result code is 401 in this case, since the server actually returns a response with an error message, you could pick up the error message from the server. But I wanted to keep this small sample here short. If the result code is not 200, then it failed, and you just display the status code and the result. So if all of that is good, and it's not if it's basically a 200 request, so the request is okay, then we deserialize the JSON and we retrieve the LOAuth object. And in that object, there's the token that we can capture. And at that point, we have the token and we can use it for whatever purposes. So in the real world application, the way this would work is I would call code like this to log in. And then once I get that token, I'm going to send that as a bearer token with the next request, which is going to say update a customer, an artist in this case. Okay. Okay, so let me show you a couple more examples of this. Let me see here, where are we? Okay, so actually, let me go to code. So if we do this here with a simple request, right? We have a www.http object and a serializer. We call the get method and we retrieve the JSON, we deserialize it, and we get a list of artists back. Okay, so if we do get artists, that's what we get, right? So this is the artist and the number of albums. So the artist and the number of albums we retrieve from this. Okay, if we get an individual artist, we're going to provide a URL that is unique for that particular artist. So the 33 in this case is the ID for that particular artist. So again, it's a unique URL that points at that particular artist. We're going to serialize it. We're going to deserialize the result, get back an artist object, and then echo back some information about that object. And then we're also going to drill into the children in this case, which is the album title for this, all the albums that are available for that particular artist, and the list of tracks. So this is a nested object that comes back, right? So if we go over here and we get the single album here, and we run this, this is the response we get. A single object with properties for the artist, then an artist embedded inside of it, a number of tracks that are recorded for that particular album. And in this case, there's only a single album that is returned. Okay? Oh, sorry, it would be single artist is what we want. I'm sorry. So artist object, which happens to have an artist embedded inside of it, the number of albums with the tracks inside of it, and that's what we display. So if we go back over here and run to get artist, here's what that looks like, right? So we have the artist information up here, the album, and then the individual songs and tracks that we're pulling out of it. So we're getting that whole nested architecture from this code right here. So we're picking it up here as this nested JSON, and we're picking it then up in FoxPro code as an object with child objects and collections inside of it. Okay, so the next example is a little more involved. That's that post example that I talked about, right? So it's a two-step process here. So let me go walk you through this one. So the first part we already saw. This is creating that username and password object, calling the authenticate method, getting the JSON back, and then deserializing and getting the token at the end of that. And if the token is empty or any of these other error occurs, then we're bonk out. Otherwise, we take the token, and then we create now another artist object, which is the object that I'm updating. Okay, so this will be the object that I'm posting to the server. So I create my object structure here, and then I serialize that into JSON. In this case, I need to pass an authorization header. So now I'm taking advantage of the headers here, and that's the metadata that describes the request, right? So I say I'm going to pass a bearer token, and the token is going to be the token that I retrieved from the login request. So the way that this works on the server looks at the bearer token and says, is this a valid token? And if it is, then it lets me in. Otherwise, I'm rejected on the server side, right? So then in order to send this now, I send it to the server to this same URL that we used on the get, but without a parameter for the actual instance. And then I pass the JSON object to it. So what that does essentially is it takes my artist that I've now made changes to, and it pushes that to the server, and the server can now save that information on the server. Okay, then the server returns to me a JSON response, which is basically the updated object. So if I add a new record, for example, I do want the updated object back so that I can retrieve the ID, for example. So on the client side, I need to be able to potentially see that. Okay, so then I take that artist and I dump it back out, same as we did in the last request. So if we do post artist, looks pretty much the same, right? The result comes back with the updated value there, but essentially we've pushed that data down. So if we go up here and we go update artist, here's what that request looks like, right? So if I run this, notice here the bearer token is set, and it tells me that it's unauthorized at this point. Okay, so notice here that it says unauthorized, so it's a 401. So this would have failed. And the reason for that is that because I haven't actually logged in. So I'm going to log in, and I'm going to take this token. And in my settings here, I'm going to add this token over here so that every request that goes to the server changes this, changes and uses this bearer token. So if I run this again, now the request works because the token that was passed here is the updated token that actually runs. Okay, same request, different behavior based on the data that is being passed. Okay. All right, so as you can see, it's a bit of work to make all this work, right? You got to keep track of the HTTP and the JSON serializer. There's actually a simpler way if you're using some of the Westwind tools. So there's a thing called JSON Service. And what this thing does is essentially abstract away all of that logic of making the HTTP call and serializing and deserializing. So what you can do with this call service is just reference a URL, and it assumes that the result that comes back is JSON and automatically gives you back an object result. So in this case, I'm calling that same artist URL, and then instead of having to do everything manually, it returns me that artist list back directly. Okay, so I get the artist name and I can edit it back. On a post operation, I can do something very similar. I can create the JSON service client, call the authenticate method, pass my user object that I've created here just as an object. I don't have to pass JSON. I pass my object, and I have to tell it in this case that I want a post operation. Check for an error, and then just use the token right here. So what this does is it simplifies and abstracts away the repetitive code of having to run an HTTP request, checking the result, and then making the JSON conversion. So it makes it a little bit easier to do this. So if we go back over into code here, if we go into get artist client, here's the get artist client, right? So if we go into FoxPro and run that, same as before, we're retrieving the items as the band and the number of albums that are being returned. And then the post client, we're posting the test. And then we're posting the updated artist. And so this one is post artist client. Okay, same thing, and you can see it worked. We get the result back from the server. Okay, so looking at these examples, of course, isn't very exciting because you just see the same thing keep coming back. But rest assured, we are going to the server and pulling that data from that remote server from these URLs, right? So just to give you an idea that this is actually true, and I'm not cheating here, let's see if I put in an invalid. So now it fails with unauthorized, right? And well, there's an error on my part, but it tells me now that it's unauthorized because I'm using an invalid username and password. Save that again, run it again, and now it should work again, okay? So we can see it's actually working. All right, so the final step then is we can wrap all of this up into something that is more self-contained and behaves more like a business object. And so the idea behind this is that a service call to a server always has a lot of repetitive things that you need to do. You need to do the JSON serialization. You need to do the HTTP conversion. You need to do you need to do the error checking. You need to make sure that the right result gets returned, exception handling, and so forth and so forth. There's a whole bunch of stuff that you have to do. And really, you do not want to do that at the application level. You want to do that inside of a sort of a business object, but instead of a business object talking to a database, we're talking about a business object that talks to the to an API service instead and provides a bunch of functionality. So the idea here is very simple. We take this JSON service class and we can subclass it. And inside of it, we can create these service methods that utilize the functionality that is available on the service class. So we basically create these wrappers that are fully self-contained, and you can call from your application without having to worry about JSON or or any HTTP functionality or error handling to the actual request. Rather, you get simple, consistent results, and you can also combine a whole bunch of things together. Okay, so let's take a look here. I'm going to take this off here, and let's go to where are we here? Here. So if we go to the artist service, I'm going to go right to the update artist because that's the one that has multiple things involved. So update artist, remember we talked about that earlier. It's actually a two-step process, right? We need to authenticate first. So there's two methods that are being called. So there's an authenticate method up here somewhere, or maybe it's down here. Update artist. Here's the authenticate method, right? So we're abstracting all of this away into its own method inside of this artist service business object class. Okay, so we create that object, we call service internally, we check the error, and then we return false if it doesn't work, or we return true if it does work, and then also set the auth token internally. So we can treat this just like a business object that has some internal logic that knows how to maintain its own state, for example. In this case, I'm setting the bearer token after this call, and then that bearer token is available. So if the bearer token is empty on the update call, then I go call authenticate. So I'm making a service call as part of the update artist automatically. So when I call this from a business logic, from a top level application, all I'm calling is this method. I'm not actually calling authenticate myself. And then we call service for the actual artists. And then we can also return a specific error result, right? So if there is an error, don't return whatever is in here, but which would be false if it completely failed, or potentially some other value that we don't know. But here we can say if there is an error, return null. Otherwise, return the updated object. Okay, so this one is artist service. Let's go into FoxPro. Oops. Oops. Oh, no. It's not artist service. That's not the one. Sorry, I'm jumping ahead here of myself. Yeah, I need to actually find this one. So the client application, so there's the artist service test. This is the one we want. Okay. So I'm loading the library for the service. I'm loading up the service, and then I'm calling get artist to make a simple call. Okay. So here's the artist list. It's the same thing. I spit it out and just display it. A single artist, same thing as we did before. I just say get artist. And in this case, get artist has a parameter of 33, and that returns me then the single individual artist. So for updating the artist, all I do with the business object, with the wrapper object, is I create an artist object and I pass that to the update artist method. Now notice again, internally, this will call authenticate to actually make that call, and authenticate as part of that request because it needs to get that token before it can be called. And then I print out the results here. So if we run this now, this should do artist service test. So there's my list of artists. That's the individual artist. And then this is the post artist. Okay. So these are the 3 requests that have gone through. So I highly recommend that you think about this particular scenario, because this is very useful in abstracting away the logic that is related to a web service and keep it all within a single class. So the class here, let me just pull it up one more time because I kind of glanced over that, is the artist service here. So it is a class that inherits from JSON client. And then each one of the methods has its own representation inside of here. And they're usually very short unless you aggregate like I do in this update method. But otherwise, this abstracts all the logic inside of this individual class. Okay. All right. Is there any questions on the client-side stuff?
Yes. Do the Westwind JSON tools handle multi-level nested JSON like 8 levels deep?
I believe so, yes. 8 levels deep. I mean, it's configurable, basically. So behind the scenes, it uses JSON.NET. So it's a .NET component that actually does the deserialization. And I believe 8 levels should be no problem. It's whatever the default is for that. And it can be changed. There's a setting in the object. So you can actually specify what the nesting level is that it will go to. But I'm pretty sure 8 levels is not going to be a problem.
Okay. With regards to your suggestion to filter data to reduce size of JSON results and parameters, define humongous, 1 megabyte, 1 gigabyte?
Multiple megabytes. I would say if you're under 20 megs, it's probably okay. I would argue that's too big, but that will work okay. Basically, you're going to have 2 issues. Number one is the download size, the download time, plus the actual time to generate the JSON. Now, the generation of JSON happens in FoxPro, so it's pretty fast, but you just have to experiment and see what works and when it gets too slow. As you know, with FoxPro, once you hit a certain string size, it starts slowing down. But you just have to experiment with that. So I would say it's going to be somewhere in the under 20 megs, you're going to be fine. But if you go over 20 megs, that's way too much. And there's no reason to ever share that much data. If you're going to have files that are that big, just figure out some other format to send it in and zip it up or something.
Okay, that's it.
That's it. Okay, so now let's look at the server side. The server side, essentially, we need some mechanism on the server to be able to serve JSON services to clients. So if you're using any sort of application framework, they typically have something built in. So if you're using .NET, there's MVC with the API part of MVC. If you're using Node, there's Express and about 10 other frameworks that you can use that are related to that. So with FoxPro, so again, I use Web Connection for this, and I don't know of any other tools that you can do this with. But basically what you need is you need to be able to have a basic FoxPro web server that has the ability to process incoming requests. And then you need the XML, the JSON tooling in order to serialize and deserialize data. So in Web Connection, which is what I'm going to show here, the tooling has all of that built into it so that you can essentially build a special process class, the WWREST process class, that allows you to create a JSON API service. And what that allows you to do is it creates endpoints in your service class that you can reference via the browser or via an API client to connect to. And so essentially what you have there is what we see on the bottom there in the code snippet, which is the authenticate snippet there. So in the authenticate snippet, what happens there is that we have a method inside of the WWREST process class. So just like any other Web Connection endpoint that goes to a request, and we have a method inside of there that can take a single parameter. So the single parameter is going to be an object or input that comes in from JSON. So this could be our LO auth object in the authentication sample. So you would, for example, get the user object with the username and password properties. So here I'm getting that passed to me, and then I can use regular business logic. In this case, I'm using a business object with the cauth, and then using the business object to authenticate and issue a token. So this creates that token object. So this is an object with parameters, and whoops, that stop. That returns that token result as an object, and it automatically gets serialized. Okay, so let me take you through this real quick. So if you've used Web Connection before, then this will all look pretty familiar. I'm just going to start up in my root directory here. So I'm going to go do console. So the console is kind of the management management console that allows me to do certain operations. So I'm going to create a new project. It's telling me it wants to be an administrator in order to configure IIS. We don't need that. But what I'm doing here is I'm creating a new project, basically. Music store process. It doesn't really matter. I'm actually not going to use this, but I'm just going to go through this to show you what it looks like to create a new project. And then we'll look at the actual project. Okay, so I'm creating a new project called Music Store, and I'm creating a process class. And that's going to be that REST process class that we add code to. And I need to create an extension. So this is basically file extension. So in order to hit a request on the server, let's say my artist request or my authenticate request, I need to have an extension on it. So it says authenticate.ms or artist.ms. So that's the way that web connection routes to your request. Okay, so the extension is what makes that possible. So then the key thing here is this JSON REST API service class. So when I do this, it creates my process class as a WW REST service that we're going to use. Now, I'm not actually going to run this because I have it already set up. And if we run it, then I just have to add a whole bunch of stuff back in. So I'm just going to cancel out of here. I do want to point out, if you have an existing application, there's also this create new process class. And that will allow you to add a new process class to an existing project as a REST service class. So you can create a new script map for that, and then that could be separately served from the rest of your application, but it's still part of that same application. Okay, I'm going to quit here. I'm going to go to the music store, and I'm going to launch. Okay, so I'm going to launch, my application. Okay, so what we have here is a web server this is my local web server that I'm running here. And this could be IIS or this could be IIS Express. I just chose the Web Connection web server, which is a built-in web server that ships with it now. Okay, then here's my Web Connection application that's running in its FoxPro window. So this is FoxPro running a server application. And then here is the demo page that was pushed up for me. Okay, so this was generated as part of a new project. So I've added some additional requests to this, but you would see these first two requests. So if I click here, you can see that it generated a test page. And in this case, the test page happens to be a JSON response. Okay, so you can see it's returning JSON to me. And same with this hello scripting world, it returns actually a cursor. It returns an object with a cursor result. So how does that work? So let me open up Visual Studio Code here. And I am going to jump into my deploy folder. So there are two directories here. The web folder contains all the web resources. So this is all the HTML pages and templates in Web Connection. In a REST service, there is really none of this is really used other than the default page, because we're basically building an API that doesn't have any user interface. So then I have a music store process class. And I'm going to go all the way to the top here and go to the test. Oops, here's the test page, right? So here's the test page. And in this case, I'm not passing a parameter. We're doing a test request, right? So if we go here and we click over here, it's just a simple get request that we're doing. And so it returns me a result here. And I'm going to go change this name to plus time. So we'll just add the time to this. And if we reload here, notice now I've added the time. And then if I add here plus FoxPro, what is it, version? Save that and reload it in here. And now there's a Visual FoxPro version. So the idea is basically that you have a simple request that can optionally take a parameter. In this case, it isn't getting one. But then we create a result. So in this case, it's an object that I'm creating, and I'm putting all these properties into it, right? I'm adding these, and then I'm returning this object back. And that's really all there is to it. That's all you have to do. Okay, and the hello script is kind of similar. It selects a bunch of records from the Web Connection log, and then creates an object from that, and adds the cursor, the result cursor of these requests, as a property to the result set there. So if we run this one more time, and hopefully this doesn't fail, there you go. So here we have message, recent requests, which is a collection of objects that are being returned, a record count, and a request name. Record count, request name. Okay, so these values are being shown up in this scenario. Okay, so the nice thing is this is all built in, right? All you have to do is return a value, and that's all it takes. Cool, right? It's pretty simple. Okay, so then if you run an artist request, let me open up another musicstore.web search. So let's hit this request. Okay, so this is actually, let me see here, where are we? So if I run this here, you'll notice now that I'm hitting this localhost 5200, which is my local web server, and it's hitting the web connection server here. So what we're looking at here is this artist request, right? So again, it's a GET request, so there's no input. We're using a business object, and we're retrieving artists. And in this case, it returns me a list of artists as a count, and it returns me a cursor called tartists. So this method actually returns a cursor list. So if I were to go into that in the business object, and we look at get artist list, there's a query that runs here, and the query method stores that query into a cursor that we specify at the end there as tartists. Okay, so again, I'm using my business object. Doesn't matter, you could use your own. You could run this query directly, or you could just do select star from artists, and that would work as well. Okay, so pretty straightforward, right? We basically just need to return a value, and that value is serialized automatically. So the next thing we can do, let's go back over here, is to get a single artist. Okay, so let's run that again, just so we can see it. And again, it's another get request, but in this case, we're saying, okay, so get an ID of 7. So we're passing a parameter there on the URL via a query string. And then the result comes back as a JSON object. So we have albums. So it's a list of albums that's returned as a top level object. And then also the artist information that is sitting at the top here, right? So we have an object that has an albums collection for all the albums, as well as properties for the artist itself. So attitude, and here's the description. This is the top level art. If we go back over into the music store here, and we have the artist record. Okay, so we're retrieving the ID from the URL. So what I'm doing is I'm taking the query string, which is whatever the value is, turning it into a number. And then skip this for now. I'll come back to this. This code here deals with basically dealing different types of requests to the same URL. I'll come back to this in a minute, but we're taking that ID and we're checking that it's not 0. And if it is 0, then we return an error response. So this allows me to return an error response that goes back as an object. So this will be the message of the object that is returned. And then this will be the status code that is returned. So rather than manually specifying that I want to return an error code and a status error code, I actually automatically serialize an object and then set the error code to that. So it's much simpler with that single line of code than having to remember, well, what property do I have to set, and what values do I have to set, and do I have to create this other object on the side? It will do all that for you. Okay, then I create an artist business object. I load the object, and that loads the individual object. And then I call load albums, which loads that collection of albums and sets the properties on that. And this happens in the business object. So in this case, that will be a collection of objects that are being sent. And then I can optionally override the way that the names represent on inside of that JSON that's returned. So by default, I guess I didn't mention this before. By default, FoxPro returns all object name property names in lowercase. And that's because when you do the reflection mechanisms in FoxPro using, I don't remember what the function is actually that you use, but the member types that you use to retrieve the information about an object, it all comes back actually uppercase. And so when JSON serializer creates object, it creates them by default using lowercase because that's much more readable than uppercase. But we don't have proper casing information about the objects at that point. So in order to get around that, you can provide this property name overrides method that allows you to provide an artist name, an image URL, all those things that need to be camel cased in this case, I can override explicitly. All the properties that are single properties that I just want to leave as is in lowercase, I can leave alone. But anything that has like uppercase letters or needs proper casing, I can just specify them here in the way I want to see them, and that's what's going to get rendered. So if we run this again here in the browser, you can see that the result that comes back, you can see here, it's Amazon URL and artist name. If I take this out, okay, I've taken it out and I'm going to rerun it. And you'll see that everything comes back. Oops, everything comes back in lowercase now. See? So I'm making the change. Save that. And by the way, for those of you that have been using Web Connection before, you might notice that the server automatically restarts. Part of the reason is that I have this live reload option that's relatively new enabled, and that every time you make a change to a PRG file in an external editor that's not locking, I can automatically rerun the request. The server at that point. So this will restart Web Connection every time I make a change. So as I type this, you can see here the server goes away and comes back. Save, comes back. Okay. All right. So the last example then is the update artist example. So in this case, we're actually receiving some data from the server. Okay. So if I set step on here, give you an idea, and let me make sure that we have debug mode on, save settings, run it one more time, and go back into the browser here. And so if I update an artist, so there it steps into my code. And so you can see here that I've received now an object, an artist object. So if I put in hello artist here, you can see that there's an object that was sent to me. So this is that object over here. Right? So we posted this request with these values, and this is exactly what we're getting here. So the Web Connection Framework and the WWREST process class takes that information and basically parses it into an object that is being passed on to me. Okay, and then I can step through the code here just like you normally do. You can do the business object operations. I can update. So here I'm sending the data, I'm loading the albums, and I'm going ahead and sending the data back to the server, and here's my response. So this is what the FoxPro code sent, right? So I was able with my FoxPro code to send this complex object back to the server as well, okay? So you have the ability to make that work fairly easily by simply, if you look at the code again, by simply passing in parameters, accepting a parameter with an object that comes in from JSON, and then simply returning a result value, either a value, an object, a collection, or a cursor. You can return any of these things simply by running through these methods. It's pretty straightforward and relatively easy to do. Okay, let me fire this back up. So we looked at the object composition part of this, right? So we can create these complex objects in FoxPro by using objects, individual properties of simple values, and collections to represent arrays. And then the collections can contain objects that are contained within them. So you can have this deep hierarchy that you can create with these tools. And this uses the same tools that we were using on the client. So it's using JSON serializer to do this. So one thing that comes up quite frequently is remember when I said at the beginning that we can have unique URLs, and a unique URL is defined by a HTTP verb and an actual URL. So we have a verb of post, and then a URL that actually points at some location. So the get and the post operation, or post and a put or a delete, might actually have different performance, different operations that occur in response to it. So in this example here, notice that the artist URL is overloaded. So I can call the artist either with an artist ID, which is the get scenario, or I can do it as a post when I'm updating, or a put which in this case is treated all as one, or delete operation, which then goes out and actually deletes the individual artist. Okay, so I can have a single request that ends up routing to another method. So I have an update artist method in my music store process class here. So there's the update artist method, right? So that comes from from this artist method. This is the update artist method that is called down there. And then the delete method, well, it's simple enough that I can just put it inside of here. But all you want to do is just take the result from this and return it. So you can break up your code with logic that serves multiple HTTP requests, all from that same artist request. Okay, so when you look at the URL for the update, right, it's localhost artist.ms, and delete, it's also artist.ms. Okay, and if I get a single artist, it's also artist.ms. So that's what this particular scenario addresses. Okay, so the last thing I want to talk about here is if you are building SPA applications. So if you are building an application like that browser application I showed at the very beginning, you will need to implement CORS. And CORS is basically a mechanism that the browser uses to ensure that the server allows access from your server. So you send an origin to the server, and the origin then is checked by the server, and you tell it whether you allow that origin. So by default, I basically allow all origins. So I capture the origin and then allow that origin, which basically means you're going to allow everything through. But you could be very specific. Maybe you only want to allow the origin to be your originating domain. Okay, so when you do this here, there's a couple of things you can do. So there's a options request that you can run. Okay, so here are those headers. So an options request will get those CORS headers from you automatically when you have it enabled. And it only happens if you have this origin in place. If I take this out and rerun this request, then that goes away. Okay, if I put it back in and run it again, then the origin header comes up. So in typical HTTP requests from a client, you don't send an origin, but when you come from a browser, it will have this origin. And then the browser will check that to ensure that the server accepts these via these CORS headers. So it's very important for SPA applications. All right, I think that's everything I have for you. Well, we had error handling. We're going to skip over that because we're out of time. So all of this information that I've just presented is available for you in the session notes and the GitHub site. All the samples are there. So all the client samples that I showed are there, as well as the web connection server application that I provided. There's a lot in that white paper. There's a lot more than what I've talked about here. There is a lot more detail and a lot more code in those things. There's 50-something pages worth. So you can take a little time. If this is interesting to you, you can take a little time and find out a lot more than what I've talked about here. So FoxPro is totally ready to do this. We do have all the tools that are available here. And so I hope you have a chance to try all of this out. So thank you very much.
Just one more question, Rick.
Okay.
What is the use case for having multiple WW processes in a single WW project?
The use case for that is that you have a single exe that runs both of those. So you don't have the overhead of having to run multiple applications, registering multiple applications, managing multiple applications. So for example, if you're building a SPA application, it's quite common to have the SPA front end have its own process class with any HTML or related requests that you might need to serve. So typically a SPA application may have 1 or 2 pages that are still static pages or HTML-based pages that are rendered. And then you have a separate process for the actual API process. So a lot of other people have maybe multiple parts of their application that they segment with these multiple process classes.
All right. That's it.
That's it. Okay.
That's it. Thanks a lot.
All right. Well, thank you again, everybody. And I'll be over in the chat room in a minute if I can figure out how to get there.